Welcome to Pure 2, the last chapter of chapter 3, which is about modeling with series and sequences, actually. So far, we have just a bit of recap before we actually dive into modeling, because I thought it's a very good time to recap on what you've learned in this chapter. Actually, there's so much you've learned in this chapter. We start off with some basic definition of sequence and series, and then you learn about arithmetic, geometric, and then actually, which isn't covered in here, which is about the what do we do again? The summation sign, sigma notation, and also the recurrence relations. But we're not talking about those two today. In this lesson, we mainly talk about arithmetic, geometric, sequence series, or sum to infinity. So you usually need to use a formula, okay, for arithmetic or geometric series sequences. In problem-solving question, you need to figure out which sequence is the right one to use. Um, yeah, so a sequence or series. So you need to know the difference between the word sequence series. So sequence means a sequence of means term by term. Okay, we're not adding together. However, for series, we're adding all together the sum. All right. So these are formula. The arithmetic sequence, un equals a plus n minus 1 times c. Geometric sequence, un equals a r to the power n minus 1. So remember, these two are finding out the nth term, a particular term. We're not working out the total. Whereas arithmetic series mean we add them all together, and geometric series. So now, whether they're given the formula booklet, I'm not too sure because the formula booklet has been updated since I drafted this notes. So do check the formula booklet, make sure the formula are given. If they're not given, make sure you remember them. And also the last one, which is a sum to infinity for geometric series. And there's one particular note for the sum to infinity, which is the ratio must be less than one for this to be valid. Okay, for this to be usable, the ratio must be less than one because convergent. Okay, we need a convergent series. That means term by term, we're adding a smaller number each time so that we have a sum to infinity. Because every time we add a smaller number, then we can add them all the numbers when they all add up together. The last term, not last term, they can't be a last term, but as in imagine a very, very long series, but every time we add a smaller number each time, then ultimately in the very, very end of the series, okay, the number will be insignificantly small. That means maybe think of like 0.00001. Then it doesn't make much difference when it adds to total. Therefore, the sum to infinity will only work when the ratio is less than one. So arithmetic series, so I'm not going to go for this. You should know this. In short, okay, this is quite important. Okay, if you're looking for the next term, sequence. If you're looking for the sum after certain years, I use years because that will be a common unit for modeling question in series and sequences. So then you look at series, the total is more about sum and the total. Okay, let's dive into the example. Example, Fatal started a business selling artworks online and George started a business selling second-hand books online. Fatal made a profit of £100 in the first month. He expects his profit to increase by 10% in each of the following month. The profit will be 133.10 pence in the fourth month. George made a profit of £150. He thinks his profit will increase by £30 in the following month. So the profit will be 240 in the fourth month. Find an expression for the total profit by Fatal in the first nth month. Now, the first question for you is, okay, is this arithmetic or geometric? Okay. Next question is this a sequence or a series? Or question A. So, question A. Okay, the answer to this two questions I'm asking is, okay, first of all, he expected his profit to increase by 10%. By 10%, that tells you it's a geometric. And in the question in part A, you want to find total profit. That means geometric series because total means you add up all together. So geometric series. So then that tells you use the formula Sn equals A times 1 minus R to the power of n, sorry, over 1 minus R. So we want to find the first nth month. So Sn equals A. The first term is 100 times 1 minus R. Now 10%, that means the multiplies 1.1. Okay, so this means R equals 1.1, not 10, not 0.1, it's 1.1 to the power of n over 1 minus 1.1. So you put in the calculator, what I'll put in the calculator is I'll just put 1,000 divided by 1 over 1.1. You should get 1,000. 1,000, oh, it's a negative 1,000. 1 minus 1.1 to the power of n. You might be thinking, so I mean, the negative in front is really insightful. What can we do? Well, we can multiply minus one into bracket, make us 1,000, bracket 1.1 n minus one. So these two are perfectly fine. Okay, the first line or second line is perfectly fine. Part B, find an expression for the total profit made by George in the first n months. Now, if you're confident, you can have a go at this question. Again, think of the question. Is it arithmetic? Is it geometric? And is it sequence or series? Okay, have a think about. Now, part B this time is arithmetic. Okay, the reason it's arithmetic is because he increased by £30. That means you're adding the same number each time. So this one, D means 30. Okay, and arithmetic series because series again because total. So arithmetic series, you remember the formula Sn equals n over 2 times 2a plus n minus 1 times d. N over 2 times 2a. 2 times a, £150 plus n minus 1 times 30. So which gives you n over 2 times 300 plus 30n minus 30, expand the bracket as well. And if I expand the bracket altogether, so 150n, or actually 300 minus 30 is 270. 270 divided by 2 is 135n plus 15n. That's the answer. Okay. N squared. N squared. Okay, 15n squared. Let me rewrite that. 15n squared. Okay, part C. Compare and comment on both Vattel's and George's model for the long-term total profit. Okay, for the long-term total profit. So this is what we can say. So what we can say is we can say Vattel's total profit. So let's compare the beginning first. Vattel's total profit is lower than George in the beginning. Okay, but it increases more rapidly as as Vattel's total profit is decided by an exponential function compared to George's quadratic function. Okay, right. Um, so okay, also it also suggests they will forever they will forever uh increase their profits, which is unrealistic. Okay, so that will be the answer. All right, so just how you compare. Okay. Example. Not really exam style, but it's just a way to sort of get you used to learning what's going on around here. You know. Right. Example. Next one. The value of a new house is £230,000. It is expected to increase in value by 12% each year. That's a crazy amount. 12% a year. Imagine. Find an expression for the value of the house after n years. So again, first question: geometric or arithmetic? Yes, geometric. Okay, what's the ratio? 1.12 because increasing, right? Increasing. So R equals 1.12. And what else? Sequence or series? You want to find the value of the house after n years. So it'll be a sequence because you're not working out total value. You're working out the new value, the nth term. So question A, you're working out the geometric sequence. Okay, so if you remember geometric sequence, so un equals ar to the power of n minus 1. So we want to work out n years. So 430,000 times 1.12 to the power of n minus 1. And that's the answer. N minus 1, n minus 1. Oh, actually, it's a new house, so expected to increase each year. If after 1 year, yeah, actually, okay, so this is the, okay, so this time, okay, now I do have to make change in here. Okay, so it will be, it will be just to the power of n. Okay, it will just be power of n. So I'll write you note in here, not to the power, not to power of n minus 1 because n minus 1 represents the nth year. So after n years means the power is n. A very simple calculation would be, if you don't understand what's going on here, a simple calculation would be, okay, how would you work out the price after 1 year? Okay, so I'll tell you. Okay, so so the final answer will be UN equals 430,000 times 1.12 to the power of n. So if you're struggling with what's going on in here, okay, think about this. After 1 year, after 1 year, the price will be U1 equals 430,000 times 1.12 to the power of 1, right? After 2 years, U2 will equal to the power of 1.12 to the power of 2, right? So you can see it's actually to the power of n. So there's something you have to be careful with the sequence series. Part B, use logarithm to forecast when the value of the house exceed 1 million, okay, to nearest year. So to exceed 1 million, so why don't we make it 1 million to start with? So let's make equals 1 million. So 1 million is 6 zeros. So we imagine 430,000 property becomes 1 million. Uh, so let's divide by 430,000. You'll be everyone will be rich. So divide by 430,000. Okay, so I got 1.12 to the power of n equals 140 over 43. To take the n down, I can log on both sides. So the question gave you the hint, you use log on both sides. But if they don't give you the hint, you have to know how to solve for n. So you can take the n down because when do we use log? We use log when n is in the power, right? So that's the whole point of using log. Log is the opposite to exponential. So n equals to log 100 over 43 divided by log 1.12. Now note, this is not log a minus b. Okay, so this is not. Okay, so what you have to do is just put in a calculator. So log 100 over 43 by divide by log 1.12. If you want to use ln, that's perfectly fine as well. So n equals to 7.447. So n equals 4.447 means, therefore, you need 8 years. Okay, 8 years. Right. Part C, comment on why this forecast may not be reliable. Again, think about long run. What does this model suggest? This model suggests the price will forever go up, which is unrealistic. So the model suggests the price will increase every year, which is unrealistic. Okay. Yeah, so that's why it's not reliable. Okay. Right. So next one. Okay. Again, if you feel free, if you think like you're confident enough, you try the question, feel free to pause video and have a go at the question. Bruce starts a new company. In first year, in year one, his profits will be 20,000. He predicts his profit to be increase by 5,000 each year. So his profits in year two are modeled to be 25,000. In year three, 30,000, so on. He predicts this will continue until he reaches annual profits of 100,000. He then models his annual profits to remain at 100,000. Calculate profits for Bruce's business in the first 20 years. Now, first of all, is this arithmetic or geometric? Arithmetic. Okay, arithmetic. Is it sequence or series? Now, this is actually a series because you can see first year is 20,000. Okay, second year, you add the 5,000 to 20,000, which is 25,000. That means you're adding up each time. Oh, actually, no, sorry, that's not the right. Sorry, that's not the right reason. Sorry, the right reason for the series is because we want to work out the first 20 years. Sorry, my bad. The total profit for the first 20 years. Sorry, my bad. Yeah, that's why series. Okay, sorry. Let me try again. Series. Okay, it's arithmetic because we're adding 5,000 each time. Okay, so this tells you we are doing arithmetic. Okay. So question A. So we'll do S20. So SN. We know it's arithmetic series. which I will write down the formula Sn equals n over 2 times 2a plus n minus 1 times d. The question is, do we use S20? No, maybe, maybe not. The reason being is he has a little special condition where when he reaches 100,000 for the profit, it'll remain there. So all we need to work out really is when does he reach the 100,000, right? Because once he has reached 100,000, they will stop there. That means the rest of the years will become 100,000. So the question is, okay, so the question is, when does he reach 100,000? Okay, this now suddenly becomes a arithmetic sequence question. It's weird, isn't it? Where they combine two in one. So un equals a plus n minus 1 times d. So let's do it. So un, we want the term to be 100,000 equals the first term, 20,000 plus n minus 1 times 5,000. So we can take the 20,000 away, so it'll be 80,000 equals to expand bracket 5,000 n minus 5,000 plus 5,000 divided by 5,000 n equals 17. That means, okay, that means he will reach 100,000 in the 17th year. So, what it means is that means on the 18th, 19th, 20th year, he will earn 100,000. So therefore, the total for 20 years equals to your S up to 17, the first 17 years, plus 100,000 times 3. So that's the total for first 17 years plus 18th, 19th, 20th years. Okay, so that's what we do, S17. So S17, oops, so S17 equals to 17 over 2 times 2 times 2a, 2 times 20,000 plus n minus 1 times d, which is all obviously you can do because we know 17 year will reach 10,000 100,000, so you can do up to 16 and plus 10,000 plus 100,000 times 4 as well. That also works. So but nevertheless, if I put this whole thing in the calculator, 2 times 20,000 plus 16 times 5,000, I got 1,020,000. So 1,020,000. That's a really profitable profitable business. So therefore total for 20 years equals to 1,020,000 plus 300,000, which is 132,000. Yeah. Okay. So just let me put in the calculator just to make sure. Yeah. Okay. So that's the answer. Okay. So this question is slightly trickier because you will have to apply actually both arithmetic sequence and series. We know 20 years. Okay. We know it doesn't earn um different amount every 20 in the 20 years because once he earned up to 100,000, then he remains there. So the question is about when does he start earning 100,000? So you can obviously count the fingers by doing 30 and 35, 40, 45. But a better way, a mathematical way will be work out the arithmetic sequence because we know it's 20,000 and then 25. Actually, that's not a good way of writing it. If I just use the first to do 20, 25, 30, 35. So when does it reach at that 100? Okay, it's actually the 17th term. Right, Poppy, is there a reason why it may not be a suitable model? Well, you can say I don't know what his business is, but it's unlikely, it's unlikely where you can earn you can earn the same profit every year. So, Poppy, you can say it is not likely that he will earn exactly um, the same amount of extra profit each year, right? So it's unlikely where he will earn extra exactly 5,000 each year. It could be 5,002, could be maybe 6,000 one year, but it could be 3,000, etc. So part C, Bruce's financial advisor says that the yearly profits are likely to increase 5% per annum. Using this model, calculate the profits for Bruce's business in the first 20 years. So that means we can now ignore the 100,000, etc. 100,000, we can just say by 5% per annum. So part C, this will be a geometric. Hopefully you will see it. This is a geometric um, sequence or series. Series, because for the first 20 years, series. Okay, with R being 1.05. So let's do that as 20 equals to A, 20,000 times 1 minus 1.05 to the power of 20 over 1 minus 1.05. So just put in the calculator is a massive number. So 20,000 times 1 minus 1.05 to the power of 20 over 1 minus 1.05. Oh, it's actually not massive difference. 66131. I mean, not as big as the number as I thought it would be. £661, 219.8 pence. Okay. Right. So if you're happy with this, okay, pause video, exam practice. Last one for the chapter. Have a go at the question. When you're ready for the answer, you can press play. Well, here are the answers. So this question is about a geometric, to tell you a geometric sequence. However, yep, so geometric sequence with ratio 1.05. So, question A, no doubt, you're just going to use a geometric series sequence formula, which is UN equals AR to the power of n minus 1. So you want it 2016. So 2016 means n will have to be 4 because 2013 is n equals 1. So U4 equals 120,000 times R, which is 1.05 to the power 4 minus 1 because it's 3, so 4, yeah, U4, because the first term is 120,000. The first term is 120,000. So next term, third term, fourth term, that's 2013, 2014, 2015, 2016. If you, in case you're struggling with this, that's why it's a 4, because you're working the fourth term in here in 2016, even there are 3 years in between. So a U4 therefore equals to 138,915. Part B, the profit will exceed the yearly profit will exceed 20,000. So again, this will becomes UN is geometric sequence equals to 20,000 200,000. So you let 20,000 times 1.05 to the power of n minus 1 equals to 200,000. Yep. Okay, and then divide by 20,000, so 1.05 to the power of n minus 1 equals to, is it just 10? 200,000 divided by, oh, hang on. It's not 1, 2. Sorry, I think I remember the number incorrectly. I think I used the number from the last question. So 120,000, which is 5 over 3. Divide it over, and then take log on both sides, or take ln. I take ln, it's the same thing. Ln 5 over 3, and then take the n minus 1 in the front. Divide it over. Okay, just put in a calculator. So ln of 5 over 3 divided by ln of 1.05 is 10.47. And if you add 1 on both sides, n equals 11.47. So that means in which year? So that means during the 11.7th year, okay, it will reach 20,000, 200,000. Therefore, 11 something will be 2024. Okay, so between therefore 2024. Now I might be thinking, why is it not 2020? Why is it not 2025? The reason being is because it's during that year. So it's between 11 to 12. That means during the 11th term. Now, if you the first term is 2013, second term is 2014, the 11th term will be 2024, right? Actually, I just paused the video. Actually, no, I made a mistake. The 11th term, no, 11th term is 2023. I was thinking that in my head. That's why I paused the video actually in my head and do that. But the first year, sorry, I actually read the question. Find the first year in which the yearly predicted profit exceed 200,000. That means the first year that will exceed 200,000 will be 2024, even though it happened during 2023. But the first year that will definitely be above it will be 2024. Right. That's right. Yes. Part C. Find the total predicted profit for 2013 to 2023 inclusive. So the tricky part for this question is about what's the value of n. So the value of n, okay, so hopefully you will recognize this is a geometric series question because of a total. So Sn equals a times 1 minus r to the power of n over 1 minus r. But the tricky part is what's the value of n? So 2013 to 2023 inclusive. Now, if you subtract them, there are 10 years, but in terms of number of terms, there are 11 terms. So it's S11, not S10. Okay, so that's the tricky part for this question. So A is 120,000 times 1 minus R to the power of 11 over 1 minus 1.05. And if you put in a calculator, times 1 minus 1.05 to the power of 11 divided by 1 minus 1.05. Yep, and you get 1704814 to nearest pound. So that's fine. Okay. Yeah, and that's the end of the chapter.